Good morning, students. It's a Friday, so congratulations. Woohoo, the week is over. So hang in there. Let's get this day over with, get this class period over with, and hope you guys have a good weekend. We have a visitor today, Mrs. Rock. She rocks, and she is there in the class today, so thank you for subbing, Mrs. Rock. And that kind of leads me to my first comment. Would you please give her homework? Give her your homework, guys. You're supposed to do your homework. And I'm going to kind of sound like the mean old hag of a teacher here, but I want to tell you something right now. I know the video didn't get started yesterday till about 8:40, and by the way, that was not my fault. I sent all the information to Mr. Harmon, and no one told me he would be out of town. Now, I'm not sure why I was contacted so late in the class period, but even though the video started late, it was just a homework video. So all you had to do was go home last night and finish watching the video. And I'm not being mean, but that's just common sense. I mean, there was no teaching yesterday. It was just a homework video. So all you had to do was go home and finish the homework and watch the homework video on your own. So please turn your homework in at this time. If you don't have it done, you'll have to make that up as soon as possible. Get that turned in. So students, Mrs. Rock, I hope someone has all of the assignments that have been turned in the whole week. Mr. Harmon should have those, and maybe Mrs. Rock can find out where they are, but there should be a yellow folder that's going to be put in my box today with all of the assignments that you students have turned in this week. So please turn your homework in. Tara, you have a test to take today, so please take your test today before the day is over. If there's a problem with that, email me. And now, I told you guys we would not have a quiz, and we're not going to have a quiz. I wouldn't lie to you. I don't lie on Fridays, and it's Friday, so I would not lie to you. But I do want you to earn some bonus points. Oops, that's a little too thick, isn't it? There we go. All right, I want you to turn to page 378, and I want you to work on numbers 1 through 9. That'll be a really pleasant review. Each one that you get correct will be half of a bonus point, so now you guys have no excuses for not having bonus points in your account. 1 through 9, half a bonus point for each one. Go ahead and pause the video because I'm going to start going over those right now. So go ahead and pause the video. Take about 5 to 10 minutes. I want you to start working on these. Let's review what we learned yesterday. And then I will very quickly go over these in class. I will not spend a lot of time on them. And then we'll go on with some notes today and some homework, unfortunately, for over the weekend. So please pause the video, take about 5 or 10 minutes, work on these 9 problems. Each one is worth half a bonus point. Okay, here we go. Let's take a look at number 1. I'm not going to be neat. I'm going to go fast. I'm going for speed. And so here we go. Number 1 says x over 16 equals 3/4. Again, we're going for speed. You understand that. Okay, let's solve for x. Cross multiply. 3 times 16 is 48, and 4 times x is 4x. Divide by 4, and 12 equals x. That's the answer to number 1. Half a bonus point if you got it right. Number 2 is 5/8 equals 25 over y. We're going to go ahead and cross multiply. 5 times y is 5y. 8 times 25 is 200. Divide both sides by 5, and you should get 40. 40 for your answer. Let's move on to number 3. Number 3 would be 11 over 2 equals z plus 3 over 6. All right, let's cross multiply. 6 times 11 is 66. Now be careful. The 2 gets multiplied by the z and a 3. So 2 times z is 2z, and 2 times 3 is 6. All right, let's subtract 6 from both sides. So a negative 6 here and a negative 6 here. That leaves us with 60 equals 2z. Divide both sides by 2, and 30 equals z. That's number 3. Okay, number 4, we are going to find the value of x. So let's see real quick here, guys. Put a line right here. I'm going to go fast on these. I'm not going to teach them like I did yesterday. The side of x corresponds with 15. So I'm going to say 15 over x. They go together. They correspond. 15 over x equals 27 over 18. Equals 27 over 18. All right. And let's see what we get here. All right, let's cross multiply. 27 times x is 27x. 15 times 18, not sure exactly what that would be. Let me do it very quickly over here for you. 120, 15. I'm getting 290, but I did that quickly. I hope that's correct. Let's see. No, 270. Sorry about that. 270. And now divide both sides by 27, and x does equal 10. So x equals 10. Again, I'm not teaching, I'm going fast, okay? All right, let's take a look at number 5. Number 5. We would say 10 corresponds with y, and 6 corresponds with 3. Cross multiply, you would get 6y equals 30. Divide by 6, and y equals 5. Y equals 5. That's number 5. And let's take a look at number 6. We're looking for x. And it looks like 8 would correspond with z. So I'm going to say 8 over z equals, and 6 would correspond with 15. So 6 over 15, cross multiply, 6 times z. 8 times 15 would be 120. Divide by 6, and z equals 20. All right, hope that helps a little bit. Let's take a look at number 7. Are they similar? If so, write a similarity statement. Okay, let's see if they are similar. Let's see, all of the angles have to be congruent on number 7. And actually, you know what? I apologize to you guys. Can we just stop right there? I'm sorry. I'm sorry to waste your time. I do plan pretty well, but you know what? 7, 8, and 9, 7 through 9 came from lesson 7.3, which I'm going to teach you today, and I just now caught that, so I'm very sorry. So we're going to be going over those later this hour. So I apologize. Let's go back. 1 through 6 is all I really needed you to do, and so half a point for each one. The most you could get from this was 3 bonus points if you got all of them right. So quickly add up your bonus points, and let's move on and take some notes. If you need to pause the video, that's fine. Do so quickly, and then let's get moving with today's notes. Okay, let's copy this heading down. We're going to learn today how to show that triangles are similar by a postulate called the AA postulate. Okay, the AA postulate, that's lesson 7.3, and the date today is the 22nd. Now, while you're writing that down, would you please listen to me for a second and just kind of listen while you're writing. Remember how we learned earlier this semester to prove triangles congruent? You don't need to write this down, but just listen to me. We learned, let's see, what were they? It was angle, angle, side was one way. Angle, side, angle was another way. Side, side, side was another way. Side, angle, side, and then hypotenuse, leg if you had a right triangle. Now, I'm not asking you to quote those or anything, but remember how we learned to prove that triangles were congruent? We learned different ways. Well, we're going to learn different ways to prove that triangles are what? Similar. We're going to learn different ways here in the next couple lessons in this chapter. So in this lesson, we're going to start off by learning one simple way to prove or to show that triangles are similar. Okay? And so here we go. I would like you to go ahead and write down this postulate. This is called the angle-angle postulate. So here we go. This is called the angle-angle similarity postulate. We call it AA. And here's what it says. Please copy this in your notes. If two angles, let me get my pen working here. If two angles of one triangle are congruent to two angles of another triangle, then we know for sure beyond the shadow of a doubt the two triangles are similar. Okay, pretty cool. So if two angles in one triangle are congruent to two angles in another triangle, then the two triangles are similar. All right, so let me go ahead and give you a little example of that. Would you please copy this into your notes? Let me get my shape recognition up here, and let's put a triangle like this. All right, there we go. And then let's enhance it very quickly here and pull it over here. I'd like you to copy this in your notes. It could be a smart thing to do. There we go. And we're going to call these two triangles similar. Now we're going to say this angle here is, oh, I don't know, we'll say 25 degrees. And we'll say this angle right here is 95 degrees. And now I'm going to come down here and I'm going to say this angle here is 25 degrees and this angle here is 95 degrees. Okay? Now, look at your postulate. It says if two angles of one triangle, here's my two angles right here, are congruent to two angles in another triangle. And here are these two angles right here. And look, this angle here is congruent to this angle here. And this angle here is congruent to this angle here. So when that happens, when you have two angles in one triangle congruent to two angles in another triangle, then you can state for sure that these two triangles are what? Similar. Let's go ahead and write a similar statement. A, B, C, D, E, F. And by the way, very quickly, let's find this third angle, shall we? We may as well. We know all three angles add up to 180 in a triangle, so this would have to be 60. And this would have to be 60. All right, so there we go. So I would state triangle A, B, C is similar to triangle, now let's be careful, A is 25 degrees, so I would put D next. My next angle is B, so F has to come next to match angle B. C is third, so angle E would have to come third. There you go. There's your similar statement. And how do you know that? By what reason? By the angle postulate. Okay, pretty cool. So let's review very quickly. Anytime two angles in one triangle are congruent to two triangles in another, then we know for sure that we have similar triangles. All right, well, let's do some practice problems here and see if we can apply this to some math. So here we go. Copy this problem in your notes, please. Okay, I know those triangles just popped up there, but go ahead and copy this in your notes. Would you very quickly draw a right angle called HGF, or a right triangle, excuse me, called HGF, and a right triangle called KLJ. Now, notice we have a right angle here and 61 degrees right here. Over here, we're going to squeeze 29 degrees in right here and a right angle here. Now, I would like you to tell me whether or not you know for sure that these two triangles are similar. Well, let's think about this. I have a right angle here. I'm going to circle it for you, so please don't miss this. And a right angle here. So I know I have one angle congruent to another angle. But in my angle postulate, I know that I have to have two angles here congruent to two angles over here. So it doesn't look like they are similar. But hold it, maybe they are. Watch this. Remember how we know how to find that third angle? Well, if you took 61 plus 90 and subtract from 180, what do you think you would get? Yep, you guessed it, 29 degrees right there. Boom. So look at that. So as soon as I found that third missing angle, I've got a right angle here and a right angle here. I have 29 degrees here. I have 29 degrees here. So yes, I can definitely state that these two triangles are similar. Remember, all that you need is two angles in one triangle congruent to two angles in another triangle. That's all that you need. Let's go ahead and try another problem. Please copy this into your notes. Okay, go ahead and draw this triangle in your notes like this, triangle RUV, and then draw a line going across here. We'll call that segment ST. Now, as you can tell, we have a little triangle. Go ahead and write in your angles here, 48 degrees right here and 48 degrees right here. Now, as you can see, we have a little triangle right here, triangle RST, and then a big triangle, triangle RUV. I want to know, are those two triangles similar? Well, at first glance, you're probably like, wow, how in the world do I know? But let's stop and think this through for a second. I'm going to take my big triangle and I'm going to write it right over here. Oh, and that's not a good job. Mr. Lemon would not be pleased. Wow, still not very good. All right, well, good enough. There's my big triangle. So we're going to call that triangle RUV. Is that good with everyone? And we're going to put 48 degrees right here. Now let's draw the little triangle up top. So here's the little triangle. There we go. And we're going to call that RST. Does everybody see that? RST. There it is. Now I'm going to go ahead and write my 48 degrees right here. Now, what did that do, Mr. Earhart? How did that help? Well, I'm glad you asked. Look, guys, they share a common angle. See this angle right here, angle R? Well, that angle is in this triangle here. I have no idea what the measurement is, but I know this angle here is the exact same angle as this angle. So I have this angle congruent to this angle. I have this angle congruent to this angle. So I have two angles in one triangle congruent to two triangles in another triangle. So yes, these two triangles are similar. Okay, pretty cool. Okay, let's keep practicing, practicing, and practicing. Okay, here we go. Let's try another problem. Okay, copy this into your notes, please. We have triangle PQS. Please copy this quickly into your notes. Triangle PQS. And then we dropped a line straight down so that it was perpendicular right here. So we have a right angle. And we're going to put 50 degrees right here. All right. And we're going to put 45 degrees right up here for that triangle. Now, you know what I'm going to ask you. Is this little triangle here, we'll call it triangle number 1, is it similar to triangle number 2? Now remember, all that you have to have is angle, angle. Two angles in one congruent to two angles in another. Now you should be able to figure this out. You really should. Look, if you've got 90 degrees here, then you know you have to have 90 degrees over here too. Because anytime two lines form 90 degrees, then you're going to have another set of 90 degrees right over here. So we know this angle here, I'm going to circle it, is congruent to this angle here. They're congruent. That's pretty obvious. Well, you know what? I'm trying to think here. I see a 50, but I see no 50 over here. I see a 45 degrees, but no 45 over here. I better find out what this third angle is. So I'm going to take 45 plus 90. That would give me 135. So this has to be 45 degrees right here. Okay, so I've got a 90 congruent to a 90. That's good. I've got a 45 congruent to nope, that's not 45. Congruent to nope, that's not 45. And if I find this angle up here, 90 plus 50 is 140, this angle here is 40. So I have one angle in one triangle congruent to one angle in another triangle, but I do not have two angles from this triangle over here congruent to two angles over here. So no, these triangles are not similar. That looks like an X. I was trying to put a slash through the similar mark. They are not similar. Okay, let's continue on, guys. Let's take notes, 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 and work hard. So here we go. Let's practice. We're learning one principle today, and we're attacking it from as many different angles as possible. Okay, so let's take a look at another problem. Almost done here. Okay, so hang in there. Let's take a look at another example. Okay, students, I would like you to copy this in your notes, please. And I want you to pause the video. After you've copied this down, let me show you what I want you to do. I want you to pause the video and see if you can figure this out on your own, okay? We have triangle U, V, Y, U, V, Y. And then we have the big triangle U, W, X. Are these two triangles, the little triangle and the big triangle, similar? Now my recommendation to you is to split the two triangles up. Okay, so I'm going to go ahead, no, I'm not going to erase this, I'll leave it here, I'm just going to move it up. But my question to you is, are these two triangles, I'll put them right down here, are these two triangles right here similar? So go ahead and pause the video, work on that for about a minute, then turn it back on and listen to the explanation. Okay, we're back. I hope that you did well. The first thing I would recommend that you do is you take the little triangle and you draw it like this. I think that'd be a very smart thing to do. And then take the big triangle and draw it like this, okay? And let's see if that helps a little bit. We're going to call this triangle U, V, Y, we know this is 90 degrees, we know this is 35 degrees. And then the big triangle would be U, W, X, and we know this is 90 degrees right here. And look at that angle right there. And that big triangle, that's also 35 degrees. They share a common angle, don't they? The little triangle here and the big triangle share this angle right there. So we have 35 degrees congruent to 35 degrees. We have 90 degrees congruent to 90 degrees. And we have learned today that if two angles in one triangle are congruent to two angles in another, then we can state the two triangles are what? Similar. But hold it. Did I write my congruency, or not congruency, did I write my similar statement correct? Well, let's see. U came first, and that's 35 degrees, so U should come first over here. V came second, and that's the angle we don't know, so W should come second, and it does. Y came third, that's the 90-degree angle, so X should come third, and it does. So yes, there we go. There's my similar statement. Let's try one more problem, and I want to give you a little closing thought to think about, and then your homework, and you can get to work on your homework. All right, so let's take a look at one more problem. Okay, I'd like you to copy these two triangles down. I'm being a little repetitive now, probably a little boring, a little redundant, but I want you guys to copy these two triangles down, and then I want you to tell me whether or not these two triangles are similar. I want you to do it on your own, so copy these down, pause the video, work it out, and then when you're done, unpause the video. Okay, students, I see that we have one angle here congruent to another angle over here, 80 and 80. However, I'm not seeing any other angles that are congruent. So I'm going to go ahead and find this missing third angle here. 80 plus 65 is 145, so this has to be 35 degrees. And now I'm going to find this missing angle right here. 80 plus 35 is 115, so I know this has to be 65 degrees. And look at that. I have an angle here congruent to an angle here, and an angle here congruent to an angle here. I even have a third angle. I don't need that, but I definitely have two angles in one triangle congruent to two angles in another, so they are similar. And go ahead and write your similar statement. Make sure you do it correctly now. Triangle TRS is similar to triangle, well, T came first, so L comes first, then R, so M would come next, and then S, so N would come next. There we go. All right. Okay. One quick comment I want to throw out to you guys. I'm going to go ahead and do it right now. Please, please listen to me. This is so important. Please listen. What I just did here is called a similarity statement. And I'm afraid you're going to get that confused with something we did yesterday. So make a note there in your notes somewhere. When I ask you to write a similarity statement, I'm referring to this. Now, when I ask you to write, and this is what we did yesterday, when I ask you to write a proportionality statement, okay, we did this yesterday. Actually 2 days ago, and then we did homework yesterday on it. But when I ask you to write a proportionality statement, here's what I'm saying to do. Your first two letters are TR. Remember this, so they go over LM. Then put an equal sign. Your next two letters are RS, so RS would go over your last two letters over here, MN. And then T and S are your first and last letters. They would correspond with L and N. That's called a proportionality statement. Do you see the difference? A similarity statement is when you state two triangles are similar and you must do it correctly. When I ask you to write a proportionality statement, like I've done here in the bottom, then I want the fractions. I want the fractions like we did yesterday. Okay, here's your homework for over the weekend. Please get started right away. I'm trying to hurry all of a sudden here so that you are able to get as much done in class as possible. You will have homework over the weekend. I'm sorry, students. I think this is the first Friday you've had homework over the weekend. I've always given you a test and a quiz and maybe small homework assignments because we've had a quiz, but never a full lesson like this. But it is what we have today, so you just have to handle that and get it done, please, over the weekend. Page 375, numbers 7 through 26, all. Now they are pretty short. Like usual, when I give you that many problems, they're going to be very easy and very quick. I'm going to go ahead and make a how to do it video now, so you can also watch that over the weekend if you need to. And if you want to look that up on YouTube to get help on your homework, it'll be Berean, just like always. You know this by now. It's Berean Academy Geometry, and then it would be 7-3, and then homework. And I know, Ashley, not to embarrass you, I know you've got some incompletes and some other students also. Please get all of your incompletes turned in, okay? Work on those over the weekend. It's very important you get those turned in. All right, if you got any questions, call me or email me.